Hello, we are starting. Still a bit of people coming from at the back. Okay, hi everyone. My name is Antoine and I work for Europeana. I'm a speaker in the coming session, but I'm also the moderator. So I would like to welcome you to this session, which is, well, let's say maybe more the technical aspects of networking data. So networking data, publishing data, accessing data is a very key topic of the conference, as we've seen. And most of the talks in the session this morning are rather about the technical aspects of it. So be ready to see a lot of architecture diagrams and things like that, but that's really important, as David reminded us. Chris Dijkshoorn is the first to speak. Actually, there are three to speak about the Rijksmuseum data services. So, Chris, the floor is yours.
Thank you very much.
And I would like to add one thing. Questions are going to be very welcome, but those are going to be at the end of the session. So after the 5 presentations that we have in the session today, there will be a 10-minute slot for questions. Everyone will come to the stage, and you can ask your questions to all at once at the same time. Thank you very much.
Thank you, Antoine. Welcome, everyone. It's really, really nice to see such a big room full of people. I've been part of the organizing committee, so that's already really nice. But what makes this even more special for me is we're presenting the new Rijksmuseum data services today. I'm going to tell you a bit about that infrastructure that we've been building these last couple of years, but I'm not the only one talking. Erwin from Q42 will actually tell about how we're using that data for the website infrastructure, and Peter Gorgels will be showing a sneak preview of our new Collectie Online platform, which is now based on linked data. I will end with the launch of the data services, where you can all find how to use them yourselves. You might be aware of that we're already in the Rijksmuseum, but what I always tell is we have a lot of objects. And actually, from those objects, we can just display 8,000 within the museum. So a big thing why we do digitization is provide access to those other 1 million objects. And what we started increasingly doing is also trying to provide wider context around that collection. Not only focusing on the objects, but also getting the context in of the books, of the archives. So nicely hooking into the keynote of this morning, the wider context of the information that as a knowledge institute you're managing. The Rijksmuseum digital strategy, you see a couple of statements: open when possible, closed when necessary, the FAIR principles, the digital and sustainable approach. These are all things that we've been working with for a couple of years and ended up for us to comprise in a really nice collection data architecture. So we drafted what we actually wanted to build a couple of years ago, and a big part of what we set out to build was the integration layer. And that is infrastructure that connects systems and makes data accessible. It's useful to, by following the principles. We have linked open data. We're using the Dutch digital heritage reference architecture, so that makes it actually usable for others than us alone. What the last sentence means, we actually take back control of those data services. So they've been running for a while. We have had a JSON API, but this was all stacked on top of our website infrastructure, which was not really in control of the museum. And what we're now doing is actually building that infrastructure ourselves and making sure that the website is using the data infrastructure that we set up. The main goal that we have with the integration layer is break down those data silos. So we have a library system, we have a collection management system, and we have a document management system. And we take all the information that's contained in those silos and get them into a triple store. And what a deliberate choice there was to not have one model to rule them all, but get the different models that capture the context of the information. So a specific model for the library, bitframe, etc., etc. And the nice thing is that we can extend this with new domains whenever it's coming in. A good thing to realize is already the Rijksmuseum is part of a global data ecosystem. So here you see 8 screenshots of different data aggregators. So all these systems and platforms are showing Rijksmuseum data. And what is good to realize is they're not always fond of using bitframe. They're not always fond of using CIDOC CRM. So we have another stack on top of this integration layer, part of that data services, that actually makes sure that we can provide multiple data models on top of those very rich domain models. This helps us to align the representation with the usage that people envision. So we can offer Europeana data model to Europeana, for example, but schema.org to our website builder that actually incorporates that to make the pages more findable. This ends up to be a Sparkle construct query that takes up the information that is needed from the triple store and converts that to the standard that we want it to be. After a while, it gets a bit messy. So after a while, and we drew this on a whiteboard, and you get a lot of standard to standard conversions. And what we also designed, and I think Edward Anderson has been really helpful in building it up as well, is the pattern book, which records the information of how you get from one model to the other model. And that makes it sort of comprehensible, but I think if we're looking for places where we can collaborate, this is really where you have standard to standard conversions, which is a great thing as a community that we can build upon. And I think that would be really welcome to have collaboration there. This will be a lot of diagrams in not a lot of time. So it's the Rijksmuseum Reconciliation crash course. And I think what is always really hard within an organization itself already is how to make sure that on the one hand you have that object, on the other hand you have the book about Rembrandt. How do you make sure that those things actually are reconciled? That the two systems know from each other that they're both about Rembrandt. What we did is actually align a lot of the concepts that we have right here with external identifiers. So we added Getty identifiers, we added Wikidata identifiers, and we created a new loop, which you see at the bottom, that actually matches those external identifiers so that we know that Rembrandt van Rijn is the same person as Rembrandt from 1606 in the library system. And at that moment that we know that, we mint a new identifier for the museum representation of Rembrandt. And at this moment, if we use it in the data services, people can just access that identifier directly to have the books about Rembrandt and the artworks by Rembrandt. This will be really useful to be the website infrastructure, and this is where I hand over the floor to Erwin.
Hi, good morning. So I'm Erwin. I'm at a digital project studio called Q42, and together with our design partners, Verbruggen, we've been working with and for the Rijksmuseum for a good 20 years. So according to David, that's not a lot of time. According to us, that's plenty, and we've got a good ride. So where do we come from? So Chris and his team are working on the new data services as they're launched today. At the same time, the people at the digital team at Rijksmuseum were ready to revamp, relaunch, reconsider the presentation online of the entire collection. So a good 10 to 12 years ago, we launched Rijksstudio, which was a major event, really sort of publishing high-res, openly available images on the web. And so we're trying to redo that entire infrastructure that has been growing over the past decade. So what were our starting points for starting anew and redoing that website? The way that we engage with the data coming from the collection system, Adlib, straight to the website was a whole lot of XSLT moderations. And a whole lot of those changes were happening on our end. Now, we're a bunch of nerds as much as you are, but we're different nerds. We love XSLTs, but it gave a sense of a lack of control for the museum themselves, who didn't always sort of know, it wasn't always transparent. If I change something in the box here in AdLib, how does that infect the website? When does that infect the website? And so what we were really trying to do, connecting to the data services, is to make sure that that whole pipeline would be more transparent, and that there's not a single decision about the content of those data that is with us, the internet people. The second is that we really try to put the objects front and center. I can hear you ask, weren't objects front and center in Rijksstudio all these years? They definitely were. But there's sort of two changes to that. As David pointed out this morning, every object has a lot of axes according to which you can plan it and see it. We try to, in the concept, use all those axes, all of the properties of an object to give different perspectives into the collection. So every object becomes a new tangent for you to explore that collection and get lost in it, and that's what Peter will show in a sneak preview. Secondly, also, because one of those the data services models that we get is linked art, and linked art is an events-based model, and so we decided to, again, after already 2 changes in models, add a third layer of transformation on top of that, because we want the object to be your entry point and not the events that surround it. Third, as much as Saskia is an advocate for the themes in our websites, we do, as internet builders, have a sense of craftsmanship, and we do want our website to be as responsive and as welcoming as possible to people. So we do want to be transparent about everything that's underlying it, but we also want sort of to keep in line that seamless experience. And so we use document stores to really engage, have rapid search, have the velocity with the mass of information, the mass of stories, the mass of data that is coming out of that website to still keep that a performance experience for users. And then finally, now we have linked data. What do we do with that linked data? So we wanted to combine that linked data into the infrastructure to make it possible to have advanced search strategies, to recommend these related concepts that we have for all those properties, and then build up a network of generated content. And again, Peter will show what that kind of looks like. So, Antoine promised you architecture diagrams. Here it comes. So we have that data services pipeline, and as sort of mentioned before, we knew we had 2 sides to that. So we need a document store, that's Elasticsearch, that was also a core part of the technology stack for Rijksstudio, and we added a graph database. In our case, we chose for Neo4j. Now, that information has to go to the website, it has to come from somewhere, so before we pull up the information from data services and pump it into those 2 stores, what Chris showed, that pattern book, there's a repository of changes. We kind of mirrored that system and added a Sparkle book, because we're doing a lot of Sparkle construct queries here to remodel that data again. That's now no longer something that we administer solely, but it's something that we do together. So whenever there's a change in the data, they can put in a pull request and we can review it and put it online. And then there's a whole bunch of enrichments happening on top of that, which together with content that the editors of the museum bring into the story all sort of need to connect and then finally become one publication on the website. So why do we want to make things as difficult as they are currently by not only changing, doing another model transformation, but also adding a secondary database into the mix? That's because we wanted to have the power of Elasticsearch for users to be able to do full text in the entire metadata and have fast and responsive faceted search. And then use a linked data graph to also enable you to have more suggestions while typing. We have this entire node structure, all of these properties that can be recommended thanks to the graph, recommend you facets, and also generating that content on the website. That's all the theory, and now let's put it into practice, and then can hand over to Peter.
Okay, thanks, Erwin. Well, I'm Peter Gorgels. I'm from the digital team. So, well, it's an exciting moment because it's the first time we show a little sneak preview of our new website. We're still building on it. The launch is 27th of November, so fingers crossed. Well, we have Rijksstudio. It was groundbreaking, I think. And what we did is we put all our images available on iOS for the whole world and encourage getting creative with the images. Now, with collection online, we're making all the collection information, data, resources, and story, everything we have available for lay people and professionals. So that's very challenging in one user interface. And we also encourage people to discover and tell their own stories, just not only get creative, but tell their own stories. Well, RecStudio was really about zooming in, high-res pictures, full screen. Collection online is about zooming out, giving new perspectives, data. Yeah, that's what we're doing now. But also, yeah, you can still zoom in. So it is an infinite zoom in, zoom out. And that's also the concept of the new collection online. It's infinite Rijksmuseum, we call it. What is your story? So it's infinite finding and discovery for all, powered by linked data with we think, an innovative search tool. Infinite connected data, themes, perspectives, we can show stories we have. And what's also very nice is that all collection data have their own automatically generated visual pages. And we also have for lay people, I think 300 accessible theme pages as an easy entrance to our collection. We also have an Art Discover AI tool to make the access even easier. And then we engage our audience with some modern new tools to make their own visual storytelling. So what we made is an infinite visual collection online discover and inspire environment where everyone can tell their own stories. So, well, this is the video we show in the header of the homepage of the new collection. You get a little bit the vibe. You can make your own gallery of honor. You can show that in a minute. And now I'll show you some screen recordings of the Dutch user interface work in progress, so bear with me. Not everything is already good in place, but you get the idea, I hope. So, well, this is the new collection homepage. You get to the Discover part with all theme pages, like a newspaper with sections. This is the daily life section. And you click on the leisure time, and then you go to, maybe you're interested in sports. Well, then you click the sport page. And this is really a curated, automatically generated node page, as we call it. All different kind of artwork, skating, golven op het ijs, that's like ice hockey from Dutch 17th century. Now, you like this artwork from Art van der Neer. We have all other kinds of skate winter sports. There are stories made by this skating artworks. And then you have the search bar. Now you see landscape, you click away, now you see moonlight. Oh, I think, oh, moonlight is really, really nice. And I think I want only see moonlight. Now you're on the moonlight generated page, but you want to see only drawings. It's tekening in Dutch. You just type tekening, you get suggestions, and you get tekeningen with moonlights. And you can infinitely go on like this. For example, you see sailboats there. You click on it, you only get one sailboat. I think, oh, well, sailboats, I liked it really. You click it, you get rid of the other things, and now you're on a totally generated sailing ship page with the most viewed artworks with sailing ships and people, artists who made a lot of those paintings. So, yeah, I hope you get a little bit the vibe that you can infinitely go on. Semantically with the search tool, but also visual. So yeah, it's I hope a really nice new environment. I also show you our new personal pages. So everybody, like RecStudio, can make their own personal pages and tell their stories. So I show you a little bit of that. This is the page of Ruben van Bamborst. Well, you can really make new sets. You can also make your gallery of honor. There's no picture there. But it will come in the next few days, fingers crossed. Well, we go to the Paris set. We all love Paris, so a little bit like Instagram, Apple Photos kind of interface. Automatically is generated a video. You can share it, so you can send this video to your girlfriend and say, well, let's go next weekend to Paris. So, yeah. And yeah, that's the power of our new personal pages. You can make also beautiful, we call it comparers. These are brush strokes, summary brush strokes. And you zoom out then and you can compare how artists made beautiful summer paintings. Well, then we go to, I think, my personal page in progress. And then I show you the Gallery of Honor. That's a very important place in well, Dutch art and history. We show here the most important things as the Rijksmuseum thinks of Dutch art and history. But now we say, well, everybody can now make their own Gallery of Honor and tell their own story, what they think is important. Well, this is a cabinet 4. You can get rid of those artworks. I'll show you how you add some new ones. You add and you get some choices and you can choose from my sets. Well, I have a set with beards. I think beards are very important in Dutch history, so I want to have beards in my Gallery of Honor. So I add them. Okay, and then I also have the last one I can add. In 8 seconds, I still have left. This is our discovery AI tool. You have a question and then you can give an answer. So what do you like? And I like walking along cliffs near the sea, near the coast. And I watch, and then you get results from it's OpenAI clip is behind it, and you can click. Yeah, you can say anything you want, so it's very easy. The entrance is very easy, also for lay people who don't know anything about art and history. And you edit. There you see the people with the beards hanging there, and there's the beach artwork. And so yeah, you can make your own Gallery of Honor. You can zoom in very deeply, go to the artwork pages, and yeah, show everybody what think you is the most important. So there's a little sneak preview. I hope you liked it.
So I'll wrap this up quickly, otherwise I'm eating too much time out of Antoine's own presentation. The launch of the collection online will be the 27th. Just to highlight, this is the first version of the integration layer and these data sources. It's something that we will build up on in the future. And we want to sort of start hooking into other environments there as well. And one of the things, we build it, now we actually want to be running it for a number of years, so really focusing on sustainability. The website is running on it, but you can actually as well use these same data services. So if you go to data.rijksmuseum.nl, you actually find the descriptions of the different data services. There will be tutorials in the near future. We were a bit occupied with organizing a conference in the meantime as well. But this will be a living thing where there is more and more to come. I'm not going to name everyone here, but a lot of people worked on this, a lot of great teams. So thank you all, and thank you for listening.
Thank you very much to the Rijksmuseum team. That's really great work. I've called Pavlos on the stage, so we're going to talk about CIDOC CRM.
Hi, thank you. So my name is Pavlos. I am an assistant professor at Technical University of Crete and affiliated researchers at FORTH. The title of my presentation is Exploring CIDOC CRM datasets with A-QuB towards a generic, user-friendly, and ready-to-use data exploration interface for end users. So I think most of you here, you know CIDOC CRM, the conceptual reference model. Just a few words. It's a theoretical and practical tool for data integration in the field of cultural heritage. It is actually a high-level event-centric ontology which provides a hierarchy of classes and properties for describing cultural heritage information. It is an ISO standard. Also, last year, there was a new version of the ISO standard. And the current community version is 7.1.3 as of February this year. And most importantly, it is the outcome of more than 25 years of collaborative development and maintenance work. So from the special interest group of CIDOC CRM, in which more than, I think, 40 organizations participate. And this is a figure on how we can use CIDOC CRM to describe information and tell stories. So the story here is that Joachim Winkelmann, a German art historian and archaeologist, saw this statue, Lagoon Group, which is a copy of an original statue in Vatican, Rome, and he was inspired to write the book History of the Art of Antiquity. So here we see how we can use the CIDOC CRM concepts to describe such information. And here we can see the usual data integration workflow, which shows how we can exploit CIDOC CRM. So the domain expert, a researcher, has collected a set of diverse data from diverse data sources, and they curate the data, they consolidate the data, and then they use a methodology like CIDOC CRM for integrating and modeling all this data, so under a common language, let's say. And then, with the support of a data engineer, the original data is transformed to a knowledge graph, a rich semantic network of integrated data. And then we have either software system that can access the knowledge graph through APIs, and as well as systems, data exploration and searching systems that try to provide a user-friendly interface for end users to access the data. And this is the focus of my presentation. So I will show you this A-QuB system and how it tries to support end users to explore the data of a knowledge graph. So it is an application that operates over a knowledge graph. It facilitates the exploration of semantic RDF data by plain users. It offers a user-friendly way to build and execute complex queries step by step. And it is highly configurable for use over any ontology or data model. And its first version was developed back in 2018 in the context of a large European project. So this is the architecture. It has the user interface, the web portal, which communicates to a set of REST web services, which in turn communicates with an RDF triple store. Okay. And this is the user interface. It's quite simple. So we start by selecting a category of entities. For example, this is a configuration for the Archaeological Museum of Messara in Heraklion, in Crete. So we have, for example, objects, monuments, places, and so on. And these categories, as I will show you later, are configured in a pre-processing step. And then we can search for entities of a specific category, for example, objects, and we get a list of results. We can start browsing the search results, so to see linked information, or we can search for more advanced, let's say, information. For example, we can search for objects that have production date, the period 8th to 6th century BC. So we can search by properties, or we can search for monuments and the objects found in them. For example, in the bottom we have Festos Palace and the objects found in Festos. And we can search for multiple criteria and so on. For example, we can search for objects that are of a specific material, of a specific cultural period, and of a specific type, let's say. And here to mention that there are also other systems that offer a similar search interface. You may know Research Space or Spark Natural, which is a JavaScript library. Both are great systems. And in A-QuB, for configuring the system for a specific case, we need to configure the entity categories. So what we saw when we click the searching button. Okay. As well as the entity relationships, how the different entities in the categories are connected. Okay. And here is an example of the configuration file. So we can configure the system through a single config.properties file. So we provide for a category the name, a SparkQL query pattern for retrieving the number of entities belonging to this category, a pattern to search for entities of this category, okay, or a pattern to show for what information to show when browsing an entity of this category, and the same for the entity relationships. Okay. So, for example, we have the relationship has material, and we provide the source and the destination entity, and the graph pattern that associates the two categories through this relationship. Now, what is the problem? The problem is that configuring the system for use in a particular use case can be very time-consuming, and it mainly depends on the complexity of the data, like the number of category relationships. Okay. And we need to define all these graph patterns for all categories and relationships. And to give you an idea, for the Messara Archaeological Museum, configuring A-QuB took several days, while for configuring the research space platform for a use case in maritime history, where we had more than 200 relationships, configuring the system took months. Okay, so it's very time-consuming. So our effort is towards a generic configuration. So how can we have a generic configuration that can be used over any dataset? And we rely on the idea of fundamental categories and relationships. There was a technical report on this. So this is a set of general categories and relationships that cover all different categories of entities and their relationships. For example, an instance of the fundamental category thing can be a museum object, a document, a song, a ship, a photograph collection, a cave, anything, okay? And so we have 7 fundamental categories: actor, place, thing, period, event, concept or type, time, and dimension. Okay, and we have configured all these categories. And we also have 116 fundamental relationships that connect the fundamental categories pairwise. For example, the first one is the actor has type concept relationship, or the other is actor was present at. And this relationship covered more specific relations. Okay. So now, when we search using this generic configuration, we can search for things. Okay, and we can get, for example, ships, as you see in the bottom. So ship is a direct or indirect subclass of thing. Okay, and here the important thing is that, of course, we need to enable inference for the subclass of relationship. And the same for the relationships. So if we search for actor who was present at a period or event, okay, so we get different we get all these results that connect these two categories of entities, actor and period, through this general property. So we get, for example, voyages or the birth events, of employment and payment events, and so on. Okay. Other important aspect to close. Inferences that should be enabled are same as, broader than, falls within, and in general, all the transitive properties. And so our short-term aim is to have publicly available deployment of this system so that anyone can directly use for exploring CIDOC CRM datasets. So we upload the dataset and we start exploring it. And this is an ongoing work. So thank you very much.
Thank you, Pavlos. So questions can be asked at the end of the session. I'd like to call on the stage Mariana.
Hello. Thank you to CIDOC and to the program committee and the local organizing committee at the Rijksmuseum. It's a great honor to be here today. My name is Mariana Lanari. I'm an artist and PhD researcher at Amsterdam School for Heritage, Memory and Material Culture at the University of Amsterdam. And since the early 2000s, I have been involved in the design, more precisely architecture of databases used in the production of exhibitions, such as the Biennial of São Paulo, 2012, to manage loans, transportation information for subtitles, wall texts, and catalogs, info about artists and organizations. I'm also part of a generation that grew up using paper dictionaries. This presentation is divided in two parts. Oh, I thought it already started. Okay. So this presentation is divided in two parts. In the first part, I will show how our work started in the Stedelijk Museum Library, and then later at the Apple Archive. And in the second part, I will show how these experiences and collaborations with archivists and librarians informed Bibliograph, a discovery interface for reading and researching in libraries and archives. So, entire collections are hidden behind a search box, making them invisible and hard to access if you don't know already what you're looking for. Another issue is that the search box in a collection interface looks similar to a search engine, but it doesn't have the same capabilities. The search engine also gives the false impression that it has everything. This is also not true. In both cases, we cannot see the size and scope, what is behind the search box. This work started in the Stedelijk Museum Library in 2015. This is the Stedelijk Museum, right behind the Rijks. And what few people know, even here in Amsterdam, is that the Stedelijk has one of the largest libraries in Europe in the field of modern and contemporary art. There are around 3 kilometers of shelves underneath the museum with more than 190,000 publications. And they are stored in the underground. Most pieces on the collection and everything on display has a bibliography underneath in the library. And my question was, how to read a library? And I imagine the library being organized like a Wikipedia, starting from one book, Writing a Sculpture by Dutch artist Lauren Weyers, which was published on the occasion of a symposium held in the museum in 1990. So I started getting books in the stacks that were mentioned in Writing a Sculpture, and these are the first books that I found. Already in the first book, I started to find stories about the museum, besides just linking books in the library. So, Writing a Sculpture shows Joseph Beuys at Documenta 7th. I got the catalog of Documenta 7th that was curated by Rudy Fuchs, who would later become director of the museum. At the moment where I was doing this, in 2015, there was an exhibition of Isa Gansken, and the first room of the exhibition was displaying exactly the same setup as in the catalog of Documenta 7. So I simulated a backchain algorithm by following citations to other books and fetching them. I gradually substituted all the 5,000 books in the reading room. This only happened thanks to the courage, I think, of Michiel Nijhoff, former director of the library, who agreed to open the library to my ambitious art project. It was very professional. I had to be hired for a year to get access to the stacks, and the whole team of the library got involved somehow. We made a parallel database with the provisory location of books updated daily, and I had the special color of the paper slip so librarians knew when a book was in the reading room. And all the books previously in the reading room were rearranged in an identical alphabetical order in the stacks, since it was used often by the museum staff. I learned a lot. First, established the links to around 500 books. And to make the links more explicit, I projected the floor plan of the museum on the bookshelf. So each shelf corresponding to a room and holding books related to the pieces on display in that room. Here on the top shelf, it's a shelf dedicated to the monumental stairs. And this yellow and white cover is a reproduction of Daniel Buren's work that was displayed also as a site-specific installation in the stairs. So with this system, the whole library could circulate and end up in the reading room. And the visitors could also visit the museum as a maquette from a bibliography perspective in the library. The research continued at the Apple. The Apple is a performance art institute founded in 1975 by V. Smalls, who had also worked at the Stedelijk Museum Library. And since the start of the Apple, she founded a documentation center. And the system she started is until today carried out by Nel Donkers. Since its inauguration in 1975, the Apple presented 1,258 events and exhibitions made in collaboration with 27,787 people, 1,001 collectives, and 3,560 institutes from 436 cities in 68 countries. It had 7 directors and 5 interim directors and occupied 8 different addresses in Amsterdam. The archive of the Apple today has around 19,000 books and 3,000 magazines, over 400,000 videos and films, audio recordings, posters, artworks, articles, and numerous photographs. This was the Apple archive in 2019. Nel Donkers invited me to collaborate on her project to make the archive fit on a container that would tour the world. To me, this was her attempt to save the archive that for many years endured a precarious situation due to budget cuts, constantly risking its continuation. At the Apple, I started already from the database. Every object received an RFID, radio frequency identification tag, with their corresponding ID in the database. To make the books more mobile, we actually ended up making the data mobile as well. And we made a simulation of moving the entire archive to the exhibition space. This is the entire archive of the Apple, including the workstations of the archivists and researchers. The books were not directly on the floor. On the bottom of each pile there is a notebook to protect them. And the books take most of the space, but there are other object types. On the sides, under the bench, there are all the press materials per year, invitations, and analog photographs. And by the stage, the hanging folders is the documentation about all the people related to events at the Apple. The most fragile materials were on the stage, but people could read supervised by the team of the archive. The amazing thing at the Apple is that people can handle rare and valuable materials. Sometimes even staff from the Stedelijk Museum comes to the archive to see something that they also have, but it's easier to get their hands on at the Apple. At the Apple, we used the drawing as a framework to create a circulation. It was a representation of how our knowledge graph works. The drawing didn't have any meaning in relation to the books, to the location of the books. It was just used for circulation. The only meaning was that there's always a model or a schema behind an application. That serves as a framework for the circulation of artifacts, information, and data that determines how information will be displayed, and the model doesn't really fit. Oh, here's the model. And the model doesn't really fit the objects it represents. There is always translation and interpretation involved. The vertical axis shows the collection and the objects, and from the character to the word, to the page, to the book, to the collection, and to the governance of the collection, everything is implicated in the issue of access. To show how the model actually works, we made these linked data cards with an explanation of our classes and how they relate, and a pencil, to show that there's always a person behind the data. Doesn't matter how big it looks like. Another common assumption is that everything is already online, which is not true. Most things at the Apple and at the Stedelijk are not digitized and cannot be found online. To facilitate digitization, we made a mobile archive unit. It's a library trolley with lights, RFID reader, and a mobile application that knows the database of the collection. When a publication is on the trolley, the app recognizes the ID of the book, and the visitor can capture images of pages that will be stored in the record of the book in the database, and will be published on bibliograph.org in real time. This method creates a shortcut in a tedious process of scanning, renaming files, and manual uploads to the database, which eventually gets then maybe published online. We made this application using an Android phone, dreaming that any archive would be able to afford it. And that we can show how a single book relates to the entire collection. You can look it up at bibliograph.org. Bibliograph is an archive interface. It works on top of existing databases. And it starts with a timeline view that in this case displays images of book covers and pages when they're being digitized. There's also a grid view to browse the collection randomly. It's a fragmented view because we are interested in giving an overview of the collection and capture relationships between objects and giving an entry point and a form of display, and not to offer entire copies of books. And you can zoom into any page. Pages are treated like images in our system, each with their own metadata, and the text is a text on this page image that is related to other pages that are part of the same record. And from every page, you can click and see the people in green and publishers or organizations in cream, and purple is the title of the object. And if you remember the image of books falling in the graph, the image is a different type of reference that becomes layered with the data in the graph view and gives provenance to the data. The colophon pages are indexed as page types and can also be used to enrich metadata with provenance. And the colors are part of the system, so they stay in every view and also across collections. This is the archive of the Jan van Eyck Academy, a multidisciplinary post-academic residency program in Maastricht, in the south of the Netherlands, using the same interface. Our ontology works as an overlay, a layer, to map data that might come from very different systems. Jan van Eyck uses OCOC, WordCat, so it's marked 21 from before several changes that can also be seen actually in the database. While the Apple has their own customized FileMaker Pro database. We also use it for data integration inside the organization. This is part of the poster collection of the Jan van Eyck, which is not in the WordCat. We capture it from their own book scanner and integrate it on Bibliograph. And for the posters, we also use automated systems like LLMs to fetch the data according to our ontology. So while they fail in the general tasks for text detection, it works surprisingly well with GraphReg. After the Apple, we were approached by Framer Framed. They wanted to use Bibliograph for their digital archive, but they don't have a physical collection. All their activities and publications since 2009 were stored in a website. That's when I realized that digital-born collections are in an even more precarious situation than the physical collections of institutions like the Apple. Several institutes nowadays rely on websites to store all their materials. Data preparation is also our secret sauce. At least it's my secret sauce, to really craft the data. All these databases are evolving for decades with a lot of people inputting data over the years, but rarely looked at what is there. The data that is found is not yet usable and needs a lot of preparation. The work is editorial and requires domain-specific knowledge. Takes time and is costly, but it's very valuable. And I think that language workers and data workers are going to be in much greater demand with AI, like starting when it starts to actually really break. At Framer Frame, we added 3 new classes: events in orange, time in blue, and series in pink. And these are all the images from the website, also in grids. And now we are studying how to interact with the data, rendering the whole view of the collection. This is all the data of Framer Frame corresponding to all the events, events descriptions, people, and organization, publications such as articles, long reads, and reports. It's much smaller than the Apple, that is much smaller than the Stedelijk, but it's also super rich and in a great detail about the program and the community. This is all the data from the library of the Jan van Eyck. These are 40,702 books and 13,000 people that are authors, translators, editors, and more than 11,000 organizations, spanning 157 years. And among these, there are also 1,089 books published by the Jan van Eyck, so the library gives actually a larger context to their own publications. And these are some views of the Apple, in this case excluding the years. So there are many possibilities. We are trying to visualize, we are trying to develop a visual language and a grammar to look at data from different perspectives. For now, each data point can be seen in relation to the whole scope, but this is just the start. Bibliograph is the visible part. In the background, there's a whole shared infrastructure. The digital archive can feed 1 or more websites, and datasets can be accessed through APIs, Sparkle queries, or exported in several formats, JSON, CSV, RDF. But is it sustainable? What we see is that there is a focus on digitization, but not always considering the widely known problems of maintaining digital infrastructures. While paper ages very slowly, the entire digital landscape will keep on changing every few years, from the infrastructure to the formats, hardware, software, and now AIs. Without considering the cost and investments involved to keep up, the results of these initiatives will all get lost as well, sooner or later. And in a broader sense, what about the ecological cost of maintaining digital applications? Who pays for it? And until when? Our concept is that the collection's data is every day better than the day before, and we are always ready to export collections and turn them into books again. A big thanks to all our partners, and thank you.
Thank you, Mariana. Well, I'm a bit in the awkward position of being the next presenter. I work at Europeana. Actually, this is going to be a shared presentation with Enno Meijers from the Koninklijke Bibliotheek in Den Haag, and we are going to talk about experiments that we've done using linked data and the International Image Interoperability Framework to innovate metadata aggregation for the common European data space for cultural heritage. So, sorry, I should. And we are not the only ones involved. There's Bob somewhere in the room here, and some other colleagues from Europeana. So I'll start with a bit of introduction. This is an illustration of how things are currently happening at Europeana. So over the past 15 years, we've been a centralized repository of metadata that gathers information coming from something like over 3,000 different cultural heritage institutions. We harvest that metadata using the OAI PMH protocol for harvesting metadata. We put that in a data repository, and that is served through various APIs through everyone who may want to reuse the data, including ourselves, because we built a website, Europeana.eu, on top of those APIs. An important linchpin in that architecture is the Europeana data model, and that has been already mentioned in the Rijksmuseum presentation. So we have our model to represent information, which is linked data enabled, so I'm not going to say much. Basically, there are objects. These objects can have digital representations, and they can be related to entities that form the context around them. That's nice, but all this is felt to be a little too centralized. Well, around us, there are things that are changing. Especially relevant is the fact that the European Union is trying to encourage the emergence of data spaces. So things that are a bit more decentralized than what Europeana has been building in the past years. And well, things stay a bit the same, but there are some changes ahead, and especially we would like to have a more decentralized approach to data aggregation. We have observed over the years that the needs of data providers and data recipients may require some solutions that are a bit more versatile. Well, yeah, to be able to cater for more varied requirements, but also to cater for more varied sources of data, and also for services that are built around the data. In the past couple of years, we had a task force that has been well, worked on in the European Aggregators Forum, trying to make the point for decentralized data aggregation, and to try to find out how this could happen, what this could mean for our domain. So what they've done is to go and inventorize well, the use cases that we have around data aggregation, and to try to extend and refine them. So I only have one example on this slide, which is that as an aggregator, I want to always provide access to data that is as fresh as possible, and as close to the source as possible. So they've inventorized those use cases, and they collected examples, and they also try to develop scenarios for new types of data and to propose solutions. And well, I've decided to pick up this use case for its illustrative value about decentralization and trying to change the way we approach the data sources within our aggregation network. So again, this is the use case of willing to provide data that is as updated as possible. And this illustration, and that's a special thought for Saskia, who said that we should not be afraid of showing some low-res picture. That's the only thing I could find, but hopefully it's gonna make the case. So we have the data source here on the left, and we have a number of aggregators that aggregate their data on the way. So There's here in this case the German digital library that gets data from them. Then there is the Archive Portal Europe aggregator that also gets data from them and from their own data processing. And then there's Europeana at the end of the food chain, so to say, that gets data well, from the two aggregators that are on the way. So that's fairly complex. And of course, it becomes even more complex when data updates are considered because, well, when the collection at source is updated, then the data goes through all those steps. And of course, the more steps there are, the more chances there are for the data not to be updated anymore, or different versions to exist, and that's not great. How nicer would it be if we would have a situation like this where the data source exists here and it's updated and every aggregator just fetches the data directly from it, and we don't care so much about trying to propagate updates across many primary sources or secondary sources. So this is what we've explored a bit, and what Enno and I want to present today. So developing solutions. So we've played with two technologies that can be used for decentralizing a bit the aggregation. The first one is IIIF. So IIIF stands for the International Image Interoperability Framework. It consists at the core of a number of APIs, so I'm showing only two of them. One is for providing access to images, and the second one is for providing, well, presentation and access information around those images, very crudely simplifying. It's also a community, which is great because there are all kind of efforts around making best practices. And we already benefit from it to get access and share rich images. So here's an example of an object that we got from Switzerland. And IIIF enables to get this object and to browse it in its all richness. And what's not shown here is the scale of the thing. This is actually a 6-meter scroll. So the ability to zoom at any point in this scroll and to get the level of detail that users require is really precious for us. And IIIF pretty much provide this out of the box. And IIIF is not only about this. So there's also some other APIs I've mentioned. One of them is called the Change Discovery API, and it's a specification to share updates about IIIF resources. So especially for supporting cases of harvesting and indexing what has been harvested. And the idea is to crawl only what is needed when there is a change in a repository, not to do everything and then figure out what has changed. So it enables publisher of data to declare a list of activities about what's happening in their repository. So when something gets created, when something gets updated, when something gets deleted, etc. And those activities, so they are provided, so thank you, Rob, for the diagram, by the way. I'm stealing that from you. You're in the room somewhere. Thank you. So there are a list of activities of those creations, updates, etc. And each activity, well, we know when it has happened, we know what it was, but it also connects to other kind of information. So in the IIIF context, we call that manifest. So they are the things that say how to present the image, but also gives access to metadata about the object that's provided in IIIF. And that metadata, that's where it can really be useful for aggregation, because it can be in any format, and especially it can be in the Europeana data model, which is good for us. So we have in the Europeana environment several partners who implemented IIIF, and one of them was interested in implementing this IIIF Change Discovery API. So that they're coming from the Czech Republic. They are the Czech Olympic Committee, and they have a collection of photographs for which they were ready to implement a IIIF Change Discovery endpoint. So we started to talk to them, and well, the result is fairly positive for the moment. So they implemented it. We are starting to ingest it. Actually, it has been ingested, but it's still in our testing environment as we speak. So hopefully, it's going to be published soon. Interestingly, the IIIF change discovery part is going fine. So the decentralized part of the aggregation is good. The obstacles, as a bit always, is about the checks of the metadata in the Europeana data model, because there can be some things about how some fields are used which are not perfect. So it goes into refinement. Here's some machine-readable metadata that proves it, but I'm not going to read it through. Well, maybe just to say that this is the list of activities. So this is the IIIF change discovery. And then this is giving the access to the metadata. So here's a link to something that's in the Europeana data model, which we can ingest within our system, and that's what it looks like in our test environment so far. But it's looking promising because we can get stuff with this new technology. So that was for IIIF, and now I would like to give the floor to Enno for telling about the second technology we've experimented with.
Thank you, Antoine. I'll try to keep up your pace. Yes, I'll be telling a little bit more about the project we did together with Europeana. I'm Enno Meijers. I work at the Dutch Digital Heritage Network, and before I tell a little bit more about the project, I'll give a short introduction about the work of the Dutch Digital Heritage Network. We started working on this program. It's a national program, and we started working on this almost 10 years ago with the first launch of our National Digital Heritage Strategy. The strategy is authorized by the Ministry of Culture, and together the network itself is governed by the national institutes in the Netherlands, working together with all the cultural heritage institutions in the whole country. And for those who are interested in getting an update, at the end of the month we will launch the third version of the strategy. So if you're interested, please feel welcome to join us on the 28th. The strategy is about improving the visibility, the usability and the sustainability of cultural heritage information in order to create more value for the user and do that in a more easy way. And the approach we chose is to go for standardization and to work together with all the partners, with all the stakeholders in the network on standards about publishing cultural heritage information and describing cultural heritage information, but also about working on sustainable collections. And currently, in the past 10 years, we worked together a lot with the vendors of the collection management systems, and currently we're at the point where we agreed upon the requirements, the NDE requirements, as we call them these days. And these are about how to approach the use of persist identifiers, publication of linked data, registering the data that you have available in a central dataset register, using standardized vocabularies through connecting to the network of terms, and last but not least, support IIIF APIs for the image API and the presentation API that Antoine just mentioned. So this is what is happening in the institutions, and all the institutions are slowly implementing these requirements and the new technology that support it. And one of the major steps we set for improving the discoverability of the information is build up a dataset register, but not in the, I could say, old-fashioned way. We really chose a decentralized approach for that. So we asked people to publish their dataset description, and our dataset register crawls the networks every day and collects all the dataset descriptions that are there. And this is a very important starting point for building services. The second thing we did on the network level was developing a search tool that does federated searches over more than 40, currently 40 different terminology sources. So if you want to describe an object in a standardized way, you can find terminology that is shared between the institutions. And of course, building on linked data, it's very important that we have well-known URIs in the data in order to know how the collections relate to each other. Well, thinking through this work and building further on the dataset register, we were very interested to think together with Europeana to see how the dataset register could play a role in delivering the data to Europeana in a different way than we did up to now. And what we actually did is based on a number of datasets that were available. We're sorry to say that they were not available in the EDM that Europeana requires. So what we did is install a pipeline that runs periodically and creates a distribution in EDM in the EDM way, and it does it based on Sparkle construct queries, which we heard already more than once, and I'm really glad about it. It's very interesting. Coming together on same ideas, I think. So this is available through our dataset register, and it's being typed as EDM. It conforms to the EDM standard. So how does the process look like in practical sense? Europeana queries the dataset register. It finds through the dataset register, it finds the link where the data can be downloaded. The data is downloaded by Europeana and ingested in the Europeana pipeline. And that's a very neat and simple process, at least on the picture, of course. There are always details to work out, but so far, I must say, we've been quite successful in getting this up. And the hard part is, of course, thinking about how to create a sustainable pipeline and who plays what role in it. Another thing is, of course, we would like to explore is the way how we can synchronize, so how we can do updates on this. And Gert-Jan is going to talk a little bit more about it in the next talk. The result is in the same testing environment as Antoine was pointing at. And it's being ingested, and it will be part of the Europeana data there. The important point for us in doing this experiment is thinking about the developments of the data spaces. And for us, it's a very interesting exploration of how, regarding our infrastructure as being a data space, how can we connect to another data space, being the common European data space for cultural heritage, where Europeana is heading, and see how you can work together and what standards are needed. And as you maybe saw in the metadata I showed, the DGET standard, which is a standard for data registers, is, in my opinion, a very important standard to look at within the data space. And we also are working on similar things connecting to research in the research infrastructures in the humanities. So that's my contribution for the talk. Thank you.
Thank you. And I've got almost nothing to do. Gert-Jan's name has already appeared on the slide, and Enno has made the transition. So, Gert-Jan, the floor is yours.
Thank you so much. Yeah, that's me. My name is Gert-Jan Filarski. I am a technical consultant working very closely with Enno at the Dutch Network for Digital Heritage. One of the other things that I did as well was being the technical lead on an initiative of the Dutch government that facilitated research as well as the restitution process of our colonial heritage. And it's very much, it's a program built for and with the nations of origin that will allow them to see what objects we have of their cultures in the Netherlands, and also how that can be, how they can file requests for restitution. So that's what I do. The work that I'll be presenting to you is very much not something that I built. I mean, I haven't written a single line of code on anything of this. I see myself mostly as someone who facilitates this kind of work. So the real work has been done by Pieter Kolpaert, probably familiar, University of Ghent, Jauko Noordzij, together with the team, with Chris's team here at the Rijksmuseum, and Anastasia Sofu from CIMIC. This is the question that I would like to be talking about. And this is a question that we've been talking about basically the entire morning. I mean, we've heard Chris talking about this, we've heard Antoine talking about this. This is what Enno has been talking about. I'm a data steward at a museum. What API should I host? It's a big question. And I would like to approach this question from the perspective, I mean, we've all heard the perspective from the data provider, right? We have an API, there is an organization behind it, and it's going to take decisions, okay, what kind of APIs am I going to provide to the rest of the world? There's actually also the other perspective, and I think that David spoke briefly about this in his keynote. It's like, let's take the perspective of actually the people using these APIs. I've taken two examples, both link to the Rijksmuseum data. There is the Asian Art Society in the Netherlands that takes a subset of the Rijksmuseum data. You've seen it also on one of the slides of Chris. And this is the one that I was closely involved with, the colonial collection. We also take a subset of the Rijksmuseum data. It's colonial data. Now, I'm going a little bit faster because I've heard already a lot of the things that I wanted to say in the previous... So this is basically, very briefly, I mean, we all like diagrams, right? So you have Asian art, you have colonial collections. They both take this subset from the Rijksmuseum. Colonial art also takes, colonial collections also takes subsets from other museums in the Netherlands. World Museum, it takes data from the Cultural Heritage Agency. It also takes data from the Ministry of Defense, Museum of Grombeek. So we bring all of this data together, which is a completely different use case than what Asian art does. But we still use overlapping data sets. This is again from the perspective of Rijksmuseum. I mean, you provide data for Asian art, you provide data for the colonial collections. There's this overlap. There's also big differences between the two. I mean, both have different features that these service platforms would like to provide. They would like to use different models to make those features actually possible. They need their own enrichments. So each of these will probably start transforming the data that they retrieve from the Rijksmuseum, will start transforming that. So again, the question, and now I'm going back to I'm putting on the hat of the Dutch National Heritage Network, is like, okay, then what are we going to have to provide? Is that a data dump? Yes, that's what NDE says. Is it a Sparkle endpoint? Yes, that's also what we would very much like. Both have their problems, I'm not going to go into them. But the point basically is if you take only the data dump, you'll just be making a copy. This is where I would really like to go. This is the perspective of the service platform. We are a cache, we're not a copy. So that's one of the things that I would immediately like to say. I don't want to be a copy. I would like to run these transformations through the network of digital heritage. That's what Anna was talking about. Retrieve the data from the providers. No. These transformations, these round trips, beautiful round trip picture that Anna showed, they should be repeatable. That's the only way that I can be a cache. What I would like to retrieve here is not constantly the entire data dump, because then I have to do all the transformation again. So I would like here to get an event stream. I would like to have an event stream of all the changes on that data screen, on that data set that I need. And that's where we are. This is basically what Antoine was talking about. It's like, you know, you want to be a decentralized system. You don't want to be another aggregator, another copy. You want to be a decentralized system that retrieves this data. We can do that with these Sparkle endpoints. We can do that with the data dumps. There's another way. Antoine was already talking about, you see it here as well, IIIF change discovery. Together with Rijksmuseum. It's the only data provider that we actually run this with. World Museum, the RCE, the Cultural Heritage Agency, Bronbeek, Ministry of Defense. We're all using the standard NDE clients, Sparkle, data dumps. But with KISS we did something, well, I thought it was really, really cool. That's the stuff, yeah, within a project, that's what makes me happy. So thank you, Chris. We made a comparison. It's like, let's take a subscription model. We used IIIF change discovery. Antoine already explained that. And we used LDAS. And let's say, okay, what's happened? So we can compare. We have two production endpoints, an LDAS endpoint and a IIIF endpoint. Together with Triply. Triply is here. We built also an LDAS client. We've built a IIIF change discovery client. So we can actually compare the subscription, the event stream model. There's a couple of things that I would like to remark on. Is IIIF change discovery, they're here. Thank you for your documentation. You made our life so much easier. Compared to LDAS, Peter knows this. Peter is the guy from LDAS. Compared to LDAS, that was a godsend. So anything that we will tell, as I said, Peter is with me, anything LDAS needs to improve on its documentation. There's a couple of technical comparisons that we can get into. I'll skip that for now. What the most important thing is that it's a matter of domain implementation. IIIF has a specific goal. It has a specific domain, while LDAS is trying to be domain agnostic. That has huge advantages. I could talk about this for hours. I will not do that. I just got the remark that I only have 2 more minutes, so I'll skip that. But I would like to end with an ambition that Peter asked me very much to convey to you, is that could we start bringing IIIF change discovery and this LDAS specification? Can we start bringing those two together? And can we start thinking about IIIF change discovery as a domain implementation of the domain agnostic LDAS? That's very much his ambition. I would love to support him in that. And then to link to the presentation that we just had, Europeana. If Europeana wants to do this, decentralized aggregation, then you're no longer an aggregator in my world. I mean, if at the moment it becomes decentralized, they've become a cache. Can we somehow start thinking about using these technologies and helping each other to see if we can bring IIIF LDAS together with this ambition of a decentralized Europeana. Now, I mean, I already got enthusiastic when Chris, but then really bouncing. I mean, that's the stuff that really gets me going. So the takeaways of this presentation. The ideal API is not Sparkle, it's not data dumps, it's very much not data dumps, it's a feed. I want event stream, I want the changes, I want happens the subscription. The specs to be considered, IIIF, change discovery, LDAS, but most of all, if there's anything that you take away, we don't want aggregators that build on other aggregators, and we don't want these copies. We want caches, we want something decentralized. Thank you so much.
Thank you very much, Gert-Jan, and don't leave actually, because I'd like all the speakers of this session to come to the floor. We are supposed to have 10 minutes for questions. Maybe that's going to be shorter because Saskia is going to rush us towards lunch. So 5 minutes, I think we have. In any case, first message is that we are all here to take questions in the lunch, in the break. So don't hesitate to come to us. But first, are there some questions in the room? And please introduce yourself and ask your question and say to you whom the question is. So, yeah.
My mic is
the mic is coming.
Hi, thank you all so much. I'm Helene from the Utrecht Archive. My question is for Chris from the Rijksmuseum team. Very impressive, both the data site and the kind of preview of what's going to happen in 2 weeks. My question is about the website part. It was really awesome, all the images and zooming in and out and the personalization in so many levels. I'm also interested in, I think, what's still coming more on the metadata side and the integration with the library and possibly the archives. Can you tell me a little bit more about that?
Sure, thank you for the question. My mic is open? Yeah. What you see here and what I try to outline as well is this is sort of modular system. We can actually hook in more systems into this integration layer. And what is nice, at the moment that we improve the data by, for example, adding these URIs, we build the bridges between those domains. So we build bridges between the library and the collection domain. So this is already integrated on the website. When you search, you actually have that reconciliation at play. What we see is the numbers are increasing. So Rembrandt has been reconciled, but we need to sort of do that for all the 60, 70,000 things that are out there. At this moment, you still search and you get to the library thing, you get to the collection object, and at the moment that we add more of these silos, you will also be able to get to the documentation that we've also been working hard on. So I think what you will see is this will develop over time and provide you access to more context around the different objects that we keep at the Rijksmuseum. Yep.
Thank you. Is there any other question in the room? Yeah, the center over there.
Hello, Maria Serres, Gallery Systems. I do have a question. I think it was Peter who presented it, also about the Rijksmuseum, the new website. You did have the AI search option there, which looked very impressive. I'd just like to know, what is the data behind? What are you kind of accessing there? Would that also be AI-generated data, or would that be the metadata tags, keywords generated by the museum staff?
Yeah, so good question. Well, the data is generated, well, I'm not so technical at this point, but I'll try to, to explain a little bit. So it's, we used a clip from OpenAI, and it's like the visual descriptions of the artworks and the similarities. That's stored in a, I think in a vector database, it's called, and we and that's used by by searching in that database. by every sentence you can use. So we always also use, I think, ChatGPT to have the large language model also for providing the prompts into the vector database. Is that an answer to your question?
Can we have one more question? There was someone in the middle raising their hand.
Benoît Dehaye, Musée d'Orsay. Thank you for your presentation. I have a question about the process and the application of the scientific expertise in the data process. We saw a very interesting image where we had a data engineer after scientific experts, but I have a question. So in the data process, there's not only technologies problematics, there's also scientific problematics. And my question is, how do we involve scientific experts, the service of documentation, in the data pipelines for control, validation, maintain, or make a correction?
Thank you. For whom do you think this question should be best addressed? Is it Mariana or the Rijks?
No, all the people are involved in those questions, I think.
Okay, well, maybe, would you like to say something, Mariana? Because you've worked with...
Could you rephrase the question, please? I didn't understand the question. Sorry.
How do we involve scientific experts in data pipelines?
Okay. So I really think that there is a need for basic data literacy, for sure, because first of all, it's not that difficult. Data experts don't need to do that much coding. It's mostly querying, which is not difficult to learn, actually, I think. And also ontologies, this is something that is very intuitive, at least on paper. It gets very technical, but on a data level, that's what I think, that more people need to be involved in data work. Yeah. This cannot really be solved by engineers. I work a lot with engineers all the time as a data person, and I see this. There's a lot of expectations that these issues are also solved in the engineering part, in code, in Python. It doesn't actually work, I think. So I think that there is no shortcut with data, but it's very interesting if you take an editorial approach. The volume of work is similar to the volume that goes into publishing any book. Yeah. So basically you do a lot of work, but this work stays. Like if you recover a field in a database that it looks unusable, you do it once. It might take a long time. It can be continuously used. So, yeah.
Can I add to that?
Okay, well, both Chris and Gert-Jan will say something.
I think what we saw when we realized this infrastructure is the data awareness within the organization is growing. First it was, what is a URI? Why are we actually adding these links to our systems? And now that we can show that these URIs that have been added to the collection management system result in the bridges to the library system, and that the librarians who have been adding these URIs actually build up a network of data, that's something that makes it more tangible and actually more understandable why we're doing this. Yeah. And another thing that I've been seeing is that at this moment we can analyze data at the dataset level instead of the object level. So you have a better overview of inconsistencies and can also feed that back to the people that are working with the content. So we're mostly, there are a lot of us that are technicians where I'm not editing the collection management system, but I can see 500 inconsistencies and say, hey, this might be an area that we can improve upon. And then that's the way that we're actually getting the sort of feedback loop growing from the sort of infrastructure and data environment towards the more content level.
Yeah. From a colonial collections project, we had exactly that problem. We had a team of data engineers, we had a team of software engineers, there was a team of domain specialists. And we brought it together into one team. So we had one team with a shared task of making this work, and then everybody has its own specialization, but you need to be talking to each other on a daily basis in a single team. And the other thing that we did is that we had monthly workshops for a much wider community, and we had data engineers, software engineers, but we also very much had the domain specialists there, and where you just explain to each other and teach each other about the different perspectives and the different issues that you're facing in your work. But this has been something that we've been doing for 18 months, every month, workshop after workshop. And that was actually something in which, I mean, if you're talking about digital literacy, but there's also domain literacy on the other side, on the engineering side. So, but that's very much what we try to do.
Well, thank you, everyone.
Yeah.
Session's over. Thank you for your attending.